When you're trying to solve a trig equation that has 2 times theta as part of your equation, you may want to use your double angle formulas. Now, we had never really referred to these identities, but they're the same deal. We can use formulas or identities to rewrite the equation that we have. And so, looking back in my formulas, I can see that the sine of 2 times theta is really the same thing as 2 times the sine of theta times the cosine of theta. And at first glance, this may seem counterintuitive because, like we've discussed in our last videos, we really like to have just sines or cosines in our problem. And I've gone ahead and, even though I had just sines, I've now introduced cosines. And so at first glance, that seems like a bad idea, but take a look at what we can actually do at this point. It's kind of an interesting way to solve the problem. If I think back to factoring, this term and this term both have something in common. In fact, they both have just a sign in them. And so what I can do is I can factor out a greatest common factor, that's the sine of theta. And so if I take that out, what's left is 2 times cosine of theta minus just 1. And because I'm equal to 0, I can finish this problem by setting each of my 2 individual factors to 0. If 2 things multiply together to equal 0, then one of those things must be 0. And so even though we now have sines and cosines mixed together in one problem, it's actually just fine to solve it because each of these individual parts does not have a sine or cosine. It's just a single sine or a single cosine in each individual piece. And so let's go ahead and continue and finish this problem solving these 2 parts. And so looking in my trig chart under the sine column, the angle that has a sine ratio of 0, there's actually 2 of them, theta could be equal to 0. That gets you a ratio of 0. Theta could also be equal to pi. Because those are quadrantal angles, I don't need to worry about figuring out what quadrant they're in, where they're positive or negative. They're not in a quadrant, they're just on the axis. On the other side of the equation then, I'm going to go ahead and add the 1 and divide by 2. And so right away I can say cosine of theta is equal to 1/2. And looking in my trig chart, the ratio, or the angle that gets me a ratio of 1/2 is pi over 3, which may or may not be an answer, just think of that as a reference angle. But because that is not a quadrantal angle, I do want to figure out the 2 quadrants that this could exist in where cosine would be positive. Well, it could be in quadrant 1 where all things are positive. And so that angle then would just be pi over 3. So the reference angle is in fact one of our solutions this time. However, cosine is also positive in quadrant 4. And so that reference angle of pi over 3 would go there. And then measuring around the circle counterclockwise, I get another solution of 5 pi over 3. And if you need help with that last part, I'd go back and watch one of those previous videos. It's the same thing we had done when we started this week out. And so we get 4 total solutions on the interval from 0 to 2 pi that would solve this equation.